Sorry everyone for the delay. Can everyone hear me? Can you guys hear me? Oh, okay, thanks. Yeah, we are sorry about that. Sorry. So I think it's already 4. We can start. So hi everyone. My name is Abdul Rahman, or just Abdel. I'm a PhD student at Mila. It's a research lab here in Montreal. I'm actually not one of the TAs for this course, but I'm just coming to give you guys this tutorial. So if you have any question related to the tutorial, I will be happy to answer it. But if your question is more related to one of the lectures or one of the assignments, I would prefer if you ask this question to one of the TAs or to Sarath himself. Yeah, so I'm gonna share my screen. Just give me 1 second. Do you guys see my screen? Let me just open the chat. You see my screen? You do?
Yes.
Okay, perfect. So we actually encourage everyone to use Google Colab. In my opinion, is the easiest way to start running Python code. So it's very easy. If we take this as the tutorial that you guys have received, I assume, you just go to File, New Notebook, and we are gonna just together see some of the things that we can do using Colab. So Colab is a product by Google. It's a free product, so you can use it without paying anything. If you want to pay, you can have some extra features. So I'm paying, so that's why mine says Google Colab Pro. So the Pro is the one that is not free, but the difference is just in giving you more GPUs and better GPUs. But in general, the free one is completely fine for the assignments. So I don't think you guys need to go for the Colab Pro. The free one is enough. It also gives you a GPU. So if you go to Edit, Notebook Settings, GPU, you can actually see that you can have a GPU if you want. But just for today, we don't really need the GPU. It's just the basics of Python. And I assume if someone already knows Python, then you can feel free to just skip the tutorial if you want. I don't think there are a lot of things that you will discover if you already know Python. But if you are new to Python, or if you want someone to just give you an introduction to Python, then of course you are welcome to continue the tutorial. So any assignment that you submit, we expect you to use Python. And Python is actually the easiest, I think, in my opinion, the easiest programming language when it comes to machine learning or reinforcement learning. And people are now using, let me just put the chat. Okay. So people are now using it in most of the recent papers, or all of the recent papers that are being published in machine learning. People normally use Python. So it's also better for you to start using Python, not other programming language. So Python is a high-level programming language, and it normally takes you less number of lines to write the same thing if you are going to write it in Python compared to other programming languages like C++, for example. So that's why we call it a high-level programming language, Python. And it's very similar to MATLAB, if you know MATLAB, to C++, to Java, if you already know them. If you don't know them, it's not a big problem. So yeah, so that's just an introduction, and let's go into how to program using Python. So similar to any programming language, you can just define your variables in like this. You can just say x equals 3, and you can also see the type of variables that you have. So I defined x equals 3, so it normally should be an integer. But if I define x equals 3.0, then the type of x is float, because I added a decimal point. So that means that x is now a floating point variable. We also have other data types, like, for example, Boolean variables. So I can define flag1 as true and flag2 as false. And I can do all of the Boolean operations that I assume that you guys know about Boolean algebra. So if you say flag1 and flag2, so basically ANDing between true and false, it should give us false, because false and anything is false. And you can also do ORing. You can say flag1 or flag2. You get true, because true or anything is true. There is the not flag1 means not true, which is false. You can also verify that flag1 is equal to flag2. So now I'm verifying whether or not they are the same. So I know that they are not the same because one of them is true and the other is false. So the result that I get is false. You can also verify that they are not the same. If verify that flag1 is not equal to flag2, and I get true because they are not the same. So similar to other programming languages, we have integers, we have floating point, we also have Boolean variables, we have strings. So I can define a string. Let's define a string that represents my name. I will make it my real name, Abdel. I can define any string I want. I can define my university, Polytechnique, for example. And normally when you add the strings, so if I add my name to my university, it gives us the concatenation of the two strings. So they have been concatenated. Abdel and Poly have become just one word. You can also put something to separate them if you want, so that they are still not together. So adding any two strings is equivalent to concatenating them. You can print the length of any string you have. So if I print the length of my name, it's 5, which is actually the number of characters that are there in my name. So my name has 5 characters, A, B, D, E, L. So you also have a lot of functions that you can do on your strings. You can say my name dot upper, just to make everything uppercase. You can say my name dot capitalize, so that you just make the first letter capital, but everything else is just as before. There are so many things that you can do for strings. You can also replace specific characters. You can say my name dot replace. I can replace, for example, the E in my name with something else. I can make it an M, so my name becomes something else, Abdel, and so on. So this is not different from other programming languages. We have strings, we have Boolean variables, we have integers and floating point variables. This is not super different. We also have something that we call containers. And containers basically include lists, dictionaries, and sets. Okay, there's also something called tuples, but let's just exclude tuples because I don't really think you will need it in your assignments. So yeah, so basically what are containers? Containers are things in Python that contain other variables. So basically a list is gonna look like this. So if I define my list to be anything, this is a list. I can easily refer to any value I want by saying my list of 0, for example. So index 0 refers to the first element in the list. Index 1 is the second element, and so on. So you start with 0. 0 is the first element. And if you want to print the last element, you say -1. So if I say my list of -1, it prints the last element. I know that this might be a bit boring if someone already knows that, I know, but it's just, yeah, it's a revision. It's not really an advanced tutorial in Python. It's just the basics of Python. So yeah, so this is basically a list. you can add, so elements that you have in your list, they don't have to be integers, all of them. You can be integers or floating point or strings or anything. So I can say my list dot append. So append is what you use when you want to add something to your list. So I want to add a string. Let's call it RL. So now my list has 10, 20, 30 and RL, which is a string. So like I said, there is no restriction on the type of variable that is being stored in your list. I can also remove elements from my list. I can say my list dot pop. So when I say my list dot pop, it prints the last element that has been added, which is RL, and also removes it. So if you print my list again, you're not gonna see the RL. It has been removed. So this is what pop does. It prints it and removes it at the same time. You can also print multiple elements. So if I want to print everything that I have, starting from a specific index to another index, I can say, let's say I want to print from index 1 to index 2, let's say index 0 to index 2. So it means from index 0, which is this guy, to index 2, which is this guy. But you have to know that in Python, the last index, the last element is going to be dropped. So you will only print 10 and 20. So this is how Python works. When you give two different indices, the first one is inclusive. It's included in the printing. And the second one is exclusive. It's not printed. So 30 is not going to be printed. Does anyone have any question on lists or on anything that we discussed? Okay. I'm going to consider this as that you don't have questions. So we have, of course, like any programming language, you can loop on everything you have in your list. You can say, for I in my list, print I. You just loop on everything that you have in your list, similar to any other programming language. It's not different. So that's it for lists. Let's see dictionaries. So dictionaries are basically used when you have something that you want to store information in. So for example, you have a company, your company, let's call it my company. And in this company, you have some information that are related to the company. So there is the year of foundation, the year in which the company was founded, let's say 1990. And there is also name of any, just number of employees, anything, number of employees. Let's say anything, 1,000. This is a dictionary. You can print it. You will just see the things that you have just given. You can retrieve any element you want inside this dictionary. If you say my company of year foundation, tells you that it has been founded in 1990. Anything that has been given. You can also add things that were not in your dictionary before. You can say my company, and let's just add something that was not there. You can add name of CEO, for example. And I'm gonna make myself the CEO. And then again, I'm gonna print the elements that I have. Now you see that the name of CEO has been added. You still have the number of employees. You still have the year of foundation. You can also remove elements from your dictionary. You can say delete my company of, delete anything you want to delete. Let's say number of employees. So if you delete that and you print the company again, you don't see the number of employees. You only see the name of CEO and the year of foundation. So basically, in any dictionary, we have what we call keys and what we call values. So this is called the key, and this is its value. this is another key, and this is its value. So we have two keys and their corresponding values. So if you ever want to print everything that you have in your dictionary, you can just loop on all of them. You can say for key, comma value in my company dot items, print key, comma value. So I'm printing everything that I have one by one. So I came here, I printed the key, then the value. Then I came here, I printed the key, then the value. Does anyone have any question? No questions? Okay, so I'm gonna proceed. So the next thing that we have is called sets. So basically sets are very similar to lists. If you recall, when I defined lists, when I said my list looks like this, sets are very, very similar, but the only difference between sets and lists is that there is no repetition in sets. So if I define my set like that, so 10, 20, 30, 10, so I have repeated 10 twice. When let's call it my set to be similar to my list, so my list and my set. When I print my set, you only see 10, 20, 30 because, like I said, there is no repetition in sets. Everything has to be unique. But that is not the case in lists. If I define my list as 10, 20, 30, 10, then there is repetition. It's okay to repeat in lists, but it is not okay to repeat in sets. Also, in sets, you cannot refer to an element using its index. You cannot say my set of 0 if you want to print the first element. It's going to give you an error. If you want to do that, you can convert it into a list. So you can say list of my set, and then you choose the index 0. Now it works, but you cannot directly say my set of 0. Of course, you can add elements to any set. You can say my set dot add, just add anything. Let's say I'm gonna add 40. So my set is now like this. You can also remove. You can say my set dot remove anything you want, and you print my set again. You don't see the 10 because I have removed it. So yeah, so it's really super simple, super really direct, and very similar to lists. You have seen how to define a set, how to find a specific, retrieve a specific element in your set, how to add and remove elements from your set. Do you guys have questions? No questions. Okay. So that's basically it for the containers that I described. So we have covered lists, dictionaries, and sets. Now let's see functions. So as we all know, programming languages do have functions. So in C++ or in Matlab or in any programming language, we have functions. And the way we define a function is super easy. You just say def, which stands for define. Then you give the name of the function. Let's call it my function. It takes an input, x. It could take multiple inputs if you want. You could make it take x, y, and z. But in the very simple case, let's just make it the only input being just x, and it returns something. Okay. So it could return anything you want. It could return an integer. It could return a float. It could return a string. It can also not return anything if you want. If you want to just print the output on the screen and that's it, if you want, you can save the output in a .text file or a .json file and that's it. You don't necessarily have to return something. But for the just sake of simplicity, let's return x times 2. Okay. Also, try to pay attention to conventions in how you name functions. So there are some conventions that make your code more readable and easier for other people to understand. So people have agreed on some conventions in how you name functions. So people normally say that it's not good to name your function like this, starting with a capital letter. So you normally use small letters. And if you have multiple words, you separate them using an underscore. This is a good way of naming your function. But Python is not going to say anything if you name it like this. It's not going to complain. It will work. The code will run. You will get the result. Everything's fine. But just for the sake of following the convention, this is the convention of that people normally use to name functions. So I will call the function. I will print my function. Sorry, my function of any input I want. I will give it for, it's giving me 8, which is x times 2. This is a super simple function. We can define something different if you want. You can say define my function, sorry, my function, let's call it my function 2, that also takes x, and let's make it a function that tells us whether x is positive or negative or 0. So you can say if x is larger than 0, then return positive. So it's going to return a string. Else if you find that x is smaller than 0, then you return negative. And if it's not larger than 0 or smaller than 0, then in this case, you return 0. So I'm going to call this function my function 2, and I'm going to give it some input, any input. Let's give it 7. It's returning positive. If I give it -7, it's returning negative. And if I give it 0, it returns 0. It's a very simple function. It just goes to the if and then else and then if and so on to determine whether x is positive, negative, or 0. Does anyone have any questions? Okay, so that means that I will proceed. So yeah, that is basically it for functions. But let's also see classes. So classes are not just in Python. You have classes in other programming languages. You have classes in C++ and Java and so on. So what is a class? A class is basically, you can think of it as, let's say you have some object, any object. Let's say the university is an object. If you want to store everything related to your object, to your university, you can define a class. You call it a university, and you store everything related to the university in this class. So what are the things that are related to the university? You name them. Name of the university, location of the university, address of the university, number of students, and so on. So inside this class, you will save all of these things. You can also have some functions that operate on these things. If you want to know whether or not this university is large, you can use the number of students that you already know to know whether it's a large university or not. If you want to know whether or not it's a rich university, you can also use the information that have been given to know whether or not it's a rich university, and so on. So let's do that. So a class is defined like this, university. Also, like I said, there are conventions in how you name classes. So normally you start with a capital letter, like here. And if you have multiple words, then you do it like this. So let's say university, anything, university campus, for example. This is how you write it. So if there are 2 words, you don't separate them with an underscore. You just write them one after the other. But the second word, the coming word, has to start with a capital letter, but everything else is small. So this is how you name a class that contains multiple words. But in our case, we just have university. And we have something that we call a constructor that's going to take the information related to the university. So this is how you define a constructor. So I said name, number of students. Let's just make it name and number of students. I think you get the idea. So I'm going to store them. So self.name equal name, self.number of students equals number of students. So if you are wondering why I'm saying self.name equal name and self.number of students equals number of students, it's basically to store the name and the number of students that are being given by the user inside. So when I say self.anything, it means that they are being stored internally. Okay, so this is how you define a class, a university. Sorry. So I wanna say my university. My university is actually an object of this class. Okay, so I will say my university is university, and I will give name and number of students. So what is the name of my university? It's called Polytechnique Montréal. So I'll just say Poly. And what is the number of students in Polytechnique Montreal? I actually don't know. I will just give any number. Let's say 10,000. This is 10,000. Yes. So this is my university. So of course, we didn't define classes just to store name and number of students. There has to be something going on inside the class. So I'm going to define a function. Let's say this function is going to tell us whether or not it's a large university. Okay. So I'm going to name this function is large. Okay. So is large is a very simple function. It checks whether the number of students is more than a certain number. If you cross the threshold, then it's a large university. Otherwise, it's a small university. So if self.number of students is more than, let's put any threshold, 15,000, then return true. True means it is a large university. Else, return false. Okay, so now I want to know whether Polytechnique is a large university or not. I will say my university dot is large. So it's telling me that no, it's not a large university because you said it has 10,000 students and the threshold for becoming a large university is 15,000 students, then it's not a large university. So you can have as many functions as you want inside your class that actually operate on the variables that you give when you define your object, which is the university. Is it clear, or does anyone have questions? So if you guys think that you understand, then say you understand, so that at least I know that you understand, because when you don't say anything, it's hard for me to know whether you understand or not. Are you still? Oh, yes, it's clear. Okay, thank you. Thank you. How to define a function with multiple input, multiple output? Yeah, you can actually return multiple things. When you say return, it does not have to be return something. It could be return, you can say return x, y, it could be multiple things, if that is the case, if that is what you're looking for. So that, but in our example, it's just return true or false because it's a Boolean function, but in general, returning does not have to be returning something. You can return multiple things. Yeah, so let me give you an example. Let's say you give the ID of the student and the function tells you the courses that this student is taking. So let's just imagine a function called courses taken. It takes the ID, it looks somewhere, and it computes X, Y, and Z, which are the strings that hold the 3 courses that this person is taking. And at the end, you just say return X, Y, Z. So you are just returning the things that you have computed, which are the names of the courses. So returning does not have to be just one thing. Okay, thanks for asking. So that is basically it for the introduction. The next thing that we have is Numpy. So Numpy is really important for many things for you in your assignments. I assume whenever you do arithmetic operations, you will use Numpy. So Numpy, when you want to use Numpy, the first thing that you have to do is just to import Numpy. So you say import Numpy as NP. And then you start defining Numpy arrays. So Numpy arrays are similar to lists. So I will define, for example, X as a Numpy array, and this is my Numpy array. If I want to know the shape of my Numpy array, so a Numpy array does not have to be a vector. It could be a vector or a matrix or anything. It depends on how you define it. So in our case, for example, if I want to know the shape of X, I say print x.shape. So it is telling me that X is a 1 by 3, which means it's a row vector. This is my X. You can define it in any way you want. And you can print type of X. Sorry. Just to make sure it's a Numpy array. You can do many things using Numpy, but if you don't want to define things in a manual way like that, you can use pre-existing functions in defining Numpy arrays. You can say numpy.zeros 3,3, for example. So I'm defining a matrix that contains zeros everywhere, and it's of dimension 3 by 3. So instead of writing them 0, 0, 9 times, I can just do it like this. So I'm using some of the pre-existing functions. I can say numpy.ones. So I guess you will know what numpy.ones means from numpy.zeros. Same thing, but ones. Of course, I choose the shape of the matrix. You can always print that shape if you want to know how it looks like. In this example, of course, you know, because you are the one who created it, but in general, just say anything.shape to know the shape of your Numpy array. There is also numpy.I, which is very useful, in my opinion. It creates an identity matrix. Of course, you know what an identity matrix is. It's a matrix that has zeros everywhere, but ones on the diagonal. And it has the property that any matrix times this identity matrix gives us the same matrix. It's just identity. That's why we call it identity. We have numpy.full. So numpy.full actually does something different. It creates a matrix of any dimension that you choose. So let's say 3 by 3, and it fills this matrix with anything that you want. So here I chose 6. So I have a 3 by 3 matrix that has the value 6 everywhere. I can say numpy.random.rand. So here I'm defining a matrix that has random values. So it has just any value, but I chose the dimension. So I'm specifying the dimension to be 3 by 4. So this is just some easy ways of creating matrices. Of course, similar to lists, if you want to find a specific element, you just do that similar to what you do in lists. So if this is X, you want to print the first element, you just say X of 0, last element X of -1, and so on. And also, if you have some condition, let's say you want to print the elements in your array, Numpy array, that satisfy some condition, you can do that. So if I define X as numpy.random.rand, anything by anything, 3 by 3, let's say. So this is my X, and I want to know what are the values that are larger than 0.5, for example. I can say print X such that X is larger than 0.5. So it's only printing the values that are larger than 0.5. So let's also do a quick check. This is one value that is larger than 0.5. It's here. This is also larger than 0.5. It's here. This is larger than 0.5. You see it here. Those two are larger than 0.5. You also see them. So it's printing whatever is satisfying the condition, regardless of what the condition is. You can also convert x from being a NumPy array that contains floating point variables to being Boolean. You can say x larger than 0.5. This gives you another NumPy array that is Boolean. So whenever this condition is satisfied, you get true. Otherwise, you get false. So it's no longer a floating point NumPy array. You can know the type of x by using x.dtype. So here x is floating point because we can see that x has floating point. It has a decimal point. But if I define x like this, x is NumPy array 1, 2, 3, and I print x.dtype, then I can see that it's just integers. So it depends on how you define it. If you define it like this using random numbers, of course it's going to be full of decimal points and it will end up being a float. But if you define it like this, it will end up being an int. Does anyone have any question? No questions? Okay. So do you guys wanna take a break? I don't mind continuing. So we have almost 25 minutes left. So I think we can take a 15 or a 10-minute break and then come back, continue what is left. So let's make it a 15-minute break. So now it's 41. It's almost 42. Let's come back at 4:57. Okay, so what is left is really not a lot. You will just see more functions, more things that you can do using NumPy. You will also see how to plot using Matplotlib library. You will see. So see you guys in 15 minutes. Okay, welcome back, everyone. I'm gonna share my screen. Can you guys see my screen? Anyone? Okay, thanks. Okay, so now we're gonna see some of the arithmetic operations that we can do using NumPy. So we have seen how to use NumPy to define different NumPy arrays, but we want to see how to multiply arrays, matrices, I mean, or how to add them, or how to find the minimum or a maximum given a specific matrix or a vector. So basically, if I define A to be a NumPy array that looks like this, 1, 2, 3, 4. So this is A. A is simply a 2 by 2 matrix that has elements 1, 2, 3, 4. And I define B to be another NumPy array that looks like this, 5, 6, 7, 8. So this is B and this is A. So let's see what are the operations that we can do on them. Both of them are 2 by 2. So first I can add them, A plus B, super simple. It's an element-wise addition. So 1 plus 5 is 6, 2 plus 6 is 8, and so on. 3 plus 7 is 10, and you can continue. You can do subtraction, super simple. 1 minus 5 is minus 4, 2 minus 4 is minus 4, 2 minus 6, I'm sorry, is minus 4, 3 minus 7 is minus 4, and so on. You can do element-wise multiplication. 1 times 5 is 5, 2 times 6 is 12, and so on. And also element-wise division. You can check, for example, 1 divided by 5 is 0.2, and so on. This is element-wise operations. In case you are wondering how to multiply the two matrices as two matrices, not element-wise, there's something that we call numpy.dot. So basically, when I say numpy.dot a comma b, it multiplies a and b as matrices. So you can also check if you want. I normally like to check whenever someone tells me anything. So just try to multiply this row by this column. Just see what you're gonna get. So 1 times 5 is 5. 2 times 7 is 14. So when you add 5 and 14, you get 19. So it's correct. You can also do another check by, for example, saying, what is numpy.dot between A and identity matrix? So you guys say, what are we gonna get if you multiply anything by identity matrix? You should get A, right? I'm not seeing anything in the chat, but I assume it's because it's a very simple question. So you get A. So you can also check that this is A. You can also find the sum of the elements in A if you want. So you say numpy.sum A. So it sums everything that you have in A. So this is A. If you say numpy.sum A, it adds 1 plus 2 plus 3 plus 4, which is 10. You can also make this summation in a different way. You can say numpy.sum A, and you say axis equals 0, meaning that you are summing, but you are summing just in one direction. So I'm gonna add 1 and 3, I get 4. I'm gonna add 2 and 4, I get 6. Do you see my cursor? You do? You do or you don't? Okay, thanks. Okay, so I'm gonna add them vertically. So that's what I get if I add just column wise. I can also add horizontally if I want. You can say numpy.sum A, and I give axis equals 1. So it's gonna add the elements in A, but horizontally. So 1 plus 2 gives us 3, and 3 plus 4 gives us 7. So you can add in any way you want. You can also find the transpose of a matrix. If this is A, then this is A transpose. Super simple, just one line. You can also find the inverse of a matrix. So if I want to find the inverse of any matrix, first I have to import something. I have to say from numpy.linear algebra import inv. Then I say inverse of A. This is going to give me the inverse of A. You can, of course, check and multiply A times A inverse. That should give you identity matrix. You do that. Okay, this is how you get the inverse. You can do so many things with numpy. You can find the maximum if you want. If you say numpy.max A, it tells you the maximum. So this is A. So it makes sense if someone tells us that the maximum is 4 because the elements are 1, 2, 3, 4. So the maximum is 4. You can find the minimum also. Minimum is 1, of course. You can find the mean of the elements in A, 2.5. This is correct because if you add them, that gives you 10. 1 plus 2 plus 3 plus 4. Then you divide by the number, which is 4. You get 2.5. You can get the standard deviation. You can do anything you want. Okay. Yeah, so this is basically it. You can also find the argmax and argmin if you want. It's just super simple. Numpy.argmax of A and argmax. There is a G. So 3, as I said before, 3 index. The first index is index of the element, index 0, then index 1, then index 2. Index 3 means the last element, and we know that the last element has the max. So this is something that makes sense. So that is basically it for numpy. Does anyone have any question? What is the dot used, please? For the dot is for multiplying two matrices. So of course, you know that in math, there are two different ways of multiplying matrices. You can multiply them just using what we know from linear algebra. You can also do element-wise multiplication. So it's not the same. If you do element-wise multiplication, you're gonna get something that is not the same as multiplication. Do you know what I mean? So, or you want me to? Okay, so let me give an example. If I have, so let's take the same example that I was using. So A and B. Element-wise multiplication gives us this. Every element is gonna be multiplied by the corresponding element. This is how you get the new matrix. So 1 times 5 is 5, 2 times 6 is 12, 3 times 7 is 21, and 4 times 8 is 32. This is element-wise multiplication. There is something else which is called multiplication. It's not called anything other than multiplication. In linear algebra, when we studied how to multiply matrices, this is not how we multiply matrices. This is just element-wise multiplication. But there is what we call matrix multiplication, which is like this. You take this row, you multiply it by this column. So the 1 is multiplied by the 5, and the 2 is multiplied by the 7, and then you add. So 1 times 5 is 5, 2 times 7 is 14. You add 5 and 14, you get 19. You do the same thing, but for the second column. So you take the same row, but with the second column. You get this guy. You change the row, you get this row. First column, you get this guy. Same row, change column, sorry. Second column, I mean, you get this guy. So this is multiplication of matrices, which is not the same as element-wise multiplication. Is it still not clear, or is it clear? I know that the name could be confusing because when you call it dot, it's not very obvious, but yeah, thank you. Okay, that is basically it for Numpy. Now we're gonna see how to, not a question, but an observation for Boolean operations with matrices. Given two matrices A and B, the using operator equal equal will return element-wise comparisons. Yes. Yeah. If you say A equal equal B, it gives us false everywhere because they are different everywhere. But if they were not different everywhere, if the first element here was a 5, we can do that actually. We can say A of 0, 0. Let's make it 5. Then we check whether they are the same or not. We get at least one true because at least one element is the same, which is the first element. Yeah, so this is a correct observation. Thank you. Yeah. So for Numpy, you can ask questions. Otherwise, I will go to plotting. So I will wait until if you guys don't have questions, I will go to plotting. If you have, I will try to answer them. You don't have questions? Okay. I know it's weekend and you want to do other things that are more interesting, but I'm really sorry for yeah. So now we have to see how to plot functions. So the first thing that you have to do is to import something called Matplotlib. So you just say import Matplotlib.plt.pyplot, sorry, as PLT. Okay. Then let's see how to plot using the scatter. So we're gonna see everything. We're gonna start with the scatter plot, then we will see how to plot a continuous function. So if I have A like this, Numpy array 1, 2, 3, 4, super simple array. B is Numpy array, another simple thing, 1, 4. So the reason why I'm saying 1, 4, 9, 16 is that I want to have samples that are taken from y equals x squared. So x has 1, 2, 3, 4, and y is 1, 4, 9, 16, so that it fits into y equals x squared. Then you just say plot.plot. You give x, you give y, then you choose any color. that you want for your figure. So I like blue. I will choose blue. So B means blue. And then you choose how to plot the scatter plot. So you can have circles, you can have squares. I will choose circles. That's it. Sorry, I didn't. Oh, I named them A and B. Okay, let's name them X and Y. Sorry. X and Y. That's it. You have 4 points, 1,1, 2,4, 3,9, and 4,16. Okay. You can give some names to the axis. I can say plot.x label. I want to name the x label as anything input. I want to name the y-axis as, let's call it output. And let's give some name to this plot. Let's say plot.title scatter plot. So we have our plot. You can see the names that I have given to x and y axis. You can also see the name of the whole plot. You can play with the color if you want. So there is blue. You can change it to R, means red. You can change it to black if you want. You can play with that if you are interested. The O is like the circles. This can also change. You can make it squares if you like squares. You can make it X's if you like that. You can make it triangles. Anyway, I don't want to. You can make so many things in your scatter plot, but this is basically how to plot a discrete function. If you guys have questions, feel free to ask. If not, I will just show you how to plot a continuous function. You guys have questions? You don't have questions. Okay, let's see how to plot a continuous function. So plotting in the continuous domain is not very different. It's just that I give so many points so that it looks like it's continuous, but the procedure is the same. So I'm going to say X is numpy arrange. I'm going to tell you what is numpy arrange. 0, 10, 0.01. So what is numpy arrange? Numpy arrange takes 3 arguments. The first argument is the starting point. The second argument is the ending point. And the third argument is the step. So it means that I want X to be all of the values between 0 and 10 with a step of 0.01. So 0, 0.01, 0.02, and so on up to 10. So if you print X, this is how it looks like. So it takes so many different values, 0, 0.010. It will go all the way up to 10 with a very, very small step. Okay, the last element is 9.99. So as I said before, it's always in Python, we ignore the last value. So this is X. Y could be anything. Let's make it sine X. Then I will say plot X, Y. I will choose blue. That's it. That's a sine wave. Let's make it a complete sine wave. So let's change the maximum to 6.5 so that it's one cycle. Yeah, this is how you plot a continuous function. You can also plot multiple. So I can call this y1. So that I can have other functions in the same plot. You can say y2 is actually numpy.cosine x, and I say plot x, y2. Let's choose a different color. I like red. I will choose red. So I'm plotting in red cosine x and in blue sine x. You can, of course, distinguish them if you want. So it's a bit hard for us because I'm the one who wrote the code. So I know that the blue one is sine and the red one is cosine. But if someone just looks on the graph, they might not know which one is the sine and which one is the cosine. So you can say, I want to have a legend. So this is when we need the legend, a legend. So you say plot.legend, and you give the first one as sine and the second one as cosine. So legend is simply going to add something here so that you know that blue means sine and red means cosine. Okay. And again, you can say plot.xlabel I want to name the x-axis as x, and I want to name the y-axis as f of x. You can also add one third function if you want. I will add a third function. I'm gonna call it, let's make it exponential minus x, so e to the minus x. I will add one line here because I need to plot it. Plot x comma y3. Let's plot it in black. Yeah, that's it. So I have e to the minus x. I can also add it to my legend so that I know which color corresponds to that. So I would add here exponential minus x. Okay, this is how you plot a continuous function. Who has questions? No questions? Nothing? Okay, so that could be because it's a bit straightforward and we are not really doing something super complicated. It could also be because you don't understand anything. I hope it's not because of that. Yeah, so one last thing I want to show you guys before I let you enjoy the weekend is how to plot on different subplots. So what if I want to show in the same figure different subplots? I want to divide my plot into, let's say, a grid, 3 different positions. In each position, I show something. So it's super simple. The first thing is the same. So I'm going to copy this part. It's not going to change. So I want to have somewhere where I have sine, somewhere where I have cosine, somewhere where I have exponential. All of them are in the same figure. Okay. So this part is not going to change. Let's copy it. Then you will say plot dot subplot. Then you give the dimensions of your subplot. So since we have 3 different functions, then it's 3 by 1. So 3 different rows and 1 column. And now I'm gonna focus on the first column. Okay, I'm gonna focus on the first row, the first subplot, I mean. Okay, which is the first function. So I give 3, 1 means 3 different rows, 1 column, and the last argument is for the one that I'm currently focusing on. So I'm currently focusing on the first one. I'm gonna say plot x comma y1, and let's give it a name. We know that y1 is sine, so we call it sine. This is how it looks like. Let's copy this part for the other subplots. So I want to plot the second one. So it's exactly the same, but you have to focus on the second. You have to take y2. You have to call it cosine. This is sine and cosine. If you want to add the third one, it's super simple. You copy, you change this to 3. So what I am changing is actually the subplot that I'm currently referring to. So currently I'm referring to the third subplot, the third position, which has y3 and which represents exponential minus x. So this is how you plot sine, cosine, and exponential on different subplots. If you ever want to do that, if you want to plot all of them on the same figure, you can do that. Any questions? No questions? Okay, if there are no questions, I just want you to know that that's basically it for the tutorial. There are some practice problems that I have added in the tutorial that you guys have. I would suggest that you try solving them by yourself, because I think we all learn more when we try things by ourselves compared to someone solving them for us. So you also have the solution, so you can look at it at the end if you give up, if you find that it's super hard, but I don't think they are super hard. We have covered everything that you need to solve those 4 problems, 4 practice problems. So try to solve them. If you don't know how to do that, look on the solution. But for today's tutorial, that's basically it. Unless you have questions, I will be happy to answer them. No questions? Comments? Anything? Any feedback? If you understand, you can just say that you understand. Okay, I'm not getting any feedback. Thank you. Yeah, thank you. You're welcome. Thank you so much. I hope you guys enjoy the weekend. And sorry for spoiling your weekend. Yeah. Thanks for coming to the tutorial. Okay, I'm gonna stop the recording if there are no questions. Also stop the sharing.